If we take a look at alkenes are organic compounds with a functional group of a double bond between the carbons, and in this case the suffix is not an ane as in alkane, but rather an ene, E-N-E, for alkenes. Right? If there is more than one double bond throughout your structure, then we say diene, triene, right, etc. So the prefix indicates how many there are. Okay. The parent chain is numbered so that the double bonds have the lowest numbers. This takes preference to side chains having the lowest numbers. Meaning if you have a chain or a structure as follows if you have something like this, if the double bond is there, alright, let's take that away. If the double bond is on carbon number 2 and you have a methyl group there, from which side will you start numbering? You'll start numbering from the left-hand side. From the left-hand side. You got two options. You can either start numbering from the left or the right. We choose the numbering that gives the double bond the lowest number. We don't give preference to the methyl group. In this case, the first thing we look at is the double bond with the lowest number. Yes, it's wrong. It's the wrong name. Otherwise. Okay. Double bonds have priority over alkyl substituents, which is what I just showed here. We'll see it now when we do examples together as well. Okay? The position of the double bonds must be indicated. You must say, where is the double bond located? So how do we do that? By putting a number in front of the suffix. You'll see what I mean by that now in the examples that we're doing. Okay. And lastly, if there's a choice of two sets of numbers for the parent chain, then that chain is chosen to give the substituents the lowest number. Meaning, if I have a double bonded carbon from this side and from that side, now we must choose, okay, so from the right it's on carbon 2, from the left it's on carbon 2. This one is closest, so we start numbering from the right. That's what they mean there. There's a lot of things that they're saying there. Let's put it into action. It's much easier to understand then. Fritz, what's your question?
What if like there's a double bond on the edge of the chain?
One there.
So like you see how that C is, see that's the substituent.
There.
If the substituent has a double bond.
Then it's not a substituent. Then that's the main chain, and this becomes the substituent.
So the double bond is always involved in the chain.
Yes. Okay. Gents, let's look at this first example. What's our first step in naming any organic compound? Find the longest chain. This isn't that difficult. It's just 3 carbons in a straight line. Okay? What is the parent of our name? If there are 3 carbons, it's meth, eth, prop. Prop. And what do we add as a suffix for alkenes? E. So it's propene. Why do I not have to give the number of the double bond here? There's only one place that it can be. No, the double bond itself is only one spot that can be. You can't, if you move the double bond to there, it'll still be in the same position. So we don't care about the numbering there, as we will care about. Mukhale, are you focusing? As we will in the second one. Ryan, your hands up.
I was just wondering, if you were to give an upgrade, we say 1 or 2.
You look at which one it's bonded to first. So carbon 1. Go. Okay. Now next one, also not difficult in obtaining the longest chain. It is just a straight chain with 1, 2, 3, 4, 5, 6 carbons. Now, where will we start numbering, gentlemen? From the left or from the right? From the right. Why do we do it from the right? The double bond is closest. So, this is carbon number 1, 2, 3, 4, 5, and 6. Let's finish just this example. Okay, then we'll take the break. Then let's get to naming. It's 6, so it's going to be hex. Okay? Then, where are the double bonds located? There and there. So on carbon number 1 and on carbon number 4. So, how are we going to get to the numbering of this? It's going to be hex 1, 4 diene.
So the smaller number is
Yes. Always from low to high. So, it's hex 1, 4 diene. Yes, we're numbering from this side. So this double bond is to the first carbon and that double bond is to the fourth carbon. Do we have that, gentlemen? Okay, cool. Thank you. Go take your break.